satellites operating in a low orbit around the Earth, providing high-speed internet on Earth and now in space.
Starship is designed to have a large surface area to create considerable drag during re-entry. Traveling at about 27,000 kilometers per hour, or almost 17,000 miles per hour, Starship compresses the air in front of it, causing the temperature of the air to rise and ionize, turning it into plasma. This plasma layer interferes with communications by absorbing and reflecting radio waves, leading to the communications blackout we've seen historically with spacecraft during atmospheric reentry. With Starship, most of that plasma is built up around the front and sides of the vehicle, leaving an opening downstream where we're able to point our Starlink terminals. And with Starlink also operating at a higher frequency than traditional space-based communications, we're able to power through any residual plasma to provide real-time video and data at high speeds back to the ground.
Super cool. We actually got to see this in action on Starship's last test flight 4, which had the first ever live HD video of a spaceship re-entering the atmosphere. SpaceX engineers were able to. This is really valuable for Starship since no spacecraft has ever flown with 4 movable flaps like what we use for aerodynamic control. Starship's greatest strength will be rapid and reliable reusability, and Starlink has become a critical tool to make that a reality.
Over the next few flights, we'll continue to improve the Starlink performance on Starship, eventually enabling more views and enabling more data to be transmitted in real time. And we'll keep experimenting during entry. You might have noticed a few tiles missing or looking different near the bottom of Starship. We intentionally placed 1 thin tile and removed 2 tiles completely. In their place, we now have sensors to see how hot things get without the tiles in those locations, while also testing some backup thermal protection options. Ideally, we expect Starship's reentry to improve on each flight, thanks in part to this wealth of new data. But if getting to space is hard, returning from space is even harder.
That's right. No one has ever succeeded in creating a fully and rapidly reusable heat shield. So we could see some spectacular failures before we get this right. But with communications improving on each flight, we will continue to gather more and more data to inform our development. We're just over 17 minutes away from the highly anticipated Starship launch. While all eyes are on the massive rocket poised on the launch pad, there's another crucial player in today's mission that deserves our attention. Let's shift our focus for a moment to discuss an additional yet equally important aspect of today's launch, the test of the Mechazilla mechanism. For the first time ever, SpaceX will attempt to catch the returning Starship using a mechanism known as Mechazilla. This towering structure, standing at the launch site, is designed to grab the massive rocket out of the air as it descends. Here's how it works. As Starship approaches for landing, Mechazilla will extend its arms, which are equipped with stabilizing pins. These pins are designed to fit into sockets on the rocket's body. Using precise timing and positioning, Mechazilla aims to catch Starship, supporting its weight and preventing it from touching the ground. The importance of this experiment cannot be overstated. If successful, it could dramatically reduce turnaround time between launches and minimize potential damage to the spacecraft during landing. This method eliminates the need for landing legs on Starship, saving weight and increasing payload capacity. Moreover, a successful catch would be a game changer for SpaceX's vision of rapid reusability. It could potentially allow for same-day reflight of Starship, a feat that seemed like science fiction just a few years ago.
In the event of a successful launch and Mechazilla test, we're expecting a special live statement from Elon Musk himself. He'll be sharing his thoughts on the significance of this milestone. So, folks, stay tuned. You might just witness history in the making today. And while we still have some time left before the launch, with the clock showing 15 minutes and 30 seconds, let's dedicate a bit more time to the technologies we plan to use in the future. These remarkable innovations promise to revolutionize space exploration and bring us closer to becoming a multiplanetary species. Starship will be taking astronauts to the moon as part of NASA's Artemis program. Next year, we plan to demonstrate ship-to-ship propellant transfer, which will be important for our upcoming moon missions. Today, we're actively testing a lot of hardware that will make exploring the moon possible. One recent series of tests brought together the key pieces we'll see when landing back on the moon: Starship, spacesuits, and astronauts.
Together with Axiom and NASA, our teams put 2 astronauts in pressurized Axiom spacesuits and practiced the first steps of going to the lunar surface. The team used test builds of a Starship airlock, as you see there, and elevator to gather data on how well future Artemis astronauts will be able to move around once fully suited. Tests like this are incredibly helpful for engineers designing these systems, as they have the opportunity to get feedback directly from experienced astronauts Peggy Whitson, who is on the right of this photo, and Doug Wheelock, who's on the left. You can see them in action during this elevator test.
SpaceX will perform one uncrewed demonstration flight before NASA's Artemis 3 mission, which will be the first human surface expedition since 1972. After those first expeditions, we'll be ready to fly more people along with everything it takes to build a moon base. In many ways, Artemis feels like an extension of the human spaceflight work SpaceX and NASA have been partnering on for some time now. In fact, we just celebrated the anniversary of the Demo 2 mission.
That's right. Just 4 years ago, on May 30th, 2020, SpaceX launched the first crewed test flight of our Crew Dragon spacecraft. Dragon carried NASA astronauts Douglas Hurley and Robert Behnken to the International Space Station in the first crewed orbital spaceflight launched from the United States since the final Space Shuttle mission in 2011, and the first ever operated by a commercial provider. You can see